Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's episode, we're going to continue looking at ranges, and this time we're going to be looking at a cool range view, which is the Cartesian product. So let's go ahead and take a look at this example here. So I'm going to go ahead into the ranges library here, and let's go ahead and search for Cartesian product view here. And basically what this is a view consisting of tuples of results calculated by the n-ary Cartesian product of the adapted views. Okay, so this is kind of a cool one. We're just gonna have a little bit of fun today and explore this. Maybe this will be interesting for you to actually see, and maybe it'll give you some ideas of algorithms or things that you're going to use here. I think this is best looked at by an example. So if you're not familiar with Cartesian product, this is the basic idea here. Let's go ahead to the, I think the Wikipedia page has a fine enough example here of basically if I have this these rows A and the columns B here, right? You can see the Cartesian product with A and B is giving me the different combinations here of A and B. So A leading here, X, Y, and Z in the first sort of element or first position here, and B the next positions here. So usually, you know, in math, we represent this with A and the Cartesian product of B, or A cross B. You know, this is the way to say it here. So I get basically all these different combinations. Now, where could this actually be useful? I mean, you could read through the, Wikipedia example. Here, it's got a nice example with cards and card suites here. Let's go ahead and just open this up here, right? Because I've got four suites. I've got, or four suits, excuse me, not just suites, suits here. So spades, hearts, clubs, and diamonds, and then the range of, 2 through 10, and then the jack, queen, king, and the ace. Okay, so that's an example of, if you're generating a card game or something that you could use this for. I thought it'd be a fun example to look at, if I was building a game like a real-time strategy game here. And just as an example here, let's see if we can get a nice snapshot of, whoever made this. Congratulations, I'm going to highlight it. But basically, what if I had a bunch of units here, like, these knights and wizards and so on, and they had different attributes in a game here, right? We can kind of keep this example in our mind here and how we would use this view here to otherwise create a bunch of units with somewhat random attributes for their like strength or their health or something in a video game. So you can take the card game example and try this out, or, something fun like a game. So anyways, Cartesian product, let's go ahead and get into the coding of this. The call signature, which is usually where I start with these things. And I'm going to look at the Cartesian product here. Again, it's any number of ranges here. So you see R's here for some number of R's. So this is a variadic argument here with the ... meaning I can, again, take any number of range-like things here. So I could have a vector with 4 suits in it, clubs, spades, diamonds, and hearts, and then another vector with those values 2 through 10, jack, queen, king, an ace, and so on. So that's the idea of how to read this. And let's see here. The rest are the concepts, otherwise defining what are the valid ranges that we can use with this. Let's see if there's any useful notes here. The Cartesian product view is a range adapter that takes n number of views, where n is greater than 0, and produces a view of tuples calculated by the n-ary Cartesian product of the provided ranges here. And I think this brings us to the Wikipedia page again here, so you can see what that looks like mathematically, if that's a little bit more useful for you. So that's the idea here. Let's just get in an example. I think we'll keep this a shorter video to just try this out here. I think there's a nice example here otherwise, but let's go ahead and add in our ranges here. Let's go to the top here. Sorry about that. Let's include ranges. I think I'm going to use maybe vector. Let's use string, something like that. Let's include print for otherwise printing out a few things here. And basically, I'm just going to create a bunch of different structures here. So the motivating example will be random units in a game generator, something like this here. And yeah, let's go ahead and figure out a few of these attributes here. So let's have some strings here. And these are just going to be names, for instance. And in fact, what I want this to be is a vector of these strings here. So something like this here. So, our units are going to say, Mike. Let's think of something more interesting like Merlin, Arthur, thinking about I don't know, King Arthur types of things here. So those could be our unit names here, right? So we could have a bunch of those here. Let's create something else here. This could be a vector of integers here, and I'll be explicit with the types here. Let's call this like health, something like that. 10, 20, 30, 40, something like that here. And let's do something else just to make them kind of interesting. Let's say like magic, something else like that here. I think that's enough here. This is enough different combinations here. And basically my idea here is that I'm going to pre-populate this structure here using the view here for the Cartesian product with all these attributes, the names, the health, and the magic. Now, if I go up here, let's go ahead and see if this is const expr. This is const expr, so potentially we can like generate this table of things at compile time, which is really, really nice. And then we could just like select from it if we wanted to create some units, okay? So let's review a few different things here. I mean, we don't want to get too carried away here, but let's just call this my, random units, and I'm going to use from ranges here. And again, this should be standard views, Cartesian product. I'm going to go ahead and get it in front of me so I don't misspell it. Cartesian product, names, health, magic. Okay. And again, this is going to give me back some tuples here. Now let's go ahead and just print these out here. Let's just use a for loop here. Auto. And let's do this by reference here. Let's say elements. And I'll just make this short here. Let's just call this U for unit here. And this will be from my random units view. And let's go ahead and print this out here. Okay, let's see what happens. Let's see if it's as simple as that. Okay, let me give this a run. Let's see here. What do I do? Cannot bind non-const L value reference of type tuple here to an hour value of type standard tuple, etc., etc., etc. So, okay, let's decipher this a little bit, because this should have been a simple example, right? I mean, in theory, if I'm looking at this, I can actually see my compilation line. You know, it's kind of curious here that let's go ahead and see the error here. It says cannot bind non-const L value reference of type. Okay, and again, it gives me this huge long tuple here to an R value of type this guy right here. Okay. So what exactly does that mean here? Well, again, it's having trouble figuring out, well, that I have this non-const L value. That's going to be the thing on here. It's a L value reference, even though we see the reference here. Again, giving us the type here into an R value, which is the random units view here that I've created here. Okay, so what can I do here? Well, I can make this not const, or rather do like something like this. Let's make sure that we save here. I think this is just going to work here. This may or may not be exactly what we want to do here, but I mean, it works here. It gives us all the different units with the different combinations here. And again, let's just make this a little bit more interesting just so you can see the values here. I'm just going to offset these values by 1 just so you can see where the, the magic and the health are being generated here. But there you go, right? I get Merlin and I get all the combinations of 10 with 11, 10 with 22, 10 with 31, 10 with 41, etc., etc., right? So this could be a quick way to generate lots and lots and lots of data here with Mike, Merlin, and Arthur here. And that is what is going on in this example here as far as binding. Now it looks like they're doing, let's see, int I, they're initializing it to 1 here, incrementing it, okay, so that they can actually like print out the tuples or whatever here. And then they have the or they have the const tuple, excuse me, on the left-hand side here. Now, in practice, if I was going to be using this, and maybe the use case for this would be, as I alluded to maybe do something like this here, where let's say we want our units here, and maybe we just want to be able to generate this, and let's do the, standard views ranges 2. Let's push this into some sort of vector. And let's see if we can do something like this here. Now I could probably get rid of the constness of this here. And I always forget, I did this in another video too. Let me find the ranges to function here. Ranges to container. Let me see if that'll link us to here. Is it in ranges? Yeah, it should be in ranges because it's giving us a concrete thing, not a view. So again, I'm going to make that mistake over and over again in my life, but that's okay. Let's see, ranges to, and then of course, let's see, I have ranges here. I have ranges, ranges colon 2. Okay, let's go ahead and scroll here, ranges. Let's see, sorry, like this. Even simpler than I thought here. I don't have to type this all out here. But this will do the trick here. And now, I mean, I have these random combinations in a container here. So let's go ahead and say, okay, what do I want to do with these random units? Well, I don't know. I mean, I've got a ton of these here. I probably don't want all of them because, again, Cartesian product is one of these things that it looks like it's kind of exploding, right? All combinations of everything is kind of bad here. So, so what can I do to kind of filter this out or limit how many things we have? Well, let's go in our ranges library. Let's see here in our adapters, what could we use here? I mean, we could start filtering these out. We could say, you know, let's just take a few of these. Like if we just need to maybe take the first like 5 units, because again, in our motivating example, right, we just want to create 5 of these like characters here. We've generated all the combinations. We've done something kind of random here, but it's kind of interesting. So let's think about this here. Let's see how to narrow this down. Actually, let's kind of build this problem here. I'm going to introduce this take here, which is a view consisting of the first n elements of another view here. Okay. So let's look at the call signature here. So again, to kind of try to figure out what this function is doing, take, okay, 2 different things here. Take, let's look at this is the one that I want here. Okay, it takes in a range, and then the range difference, okay, that's the count here. Okay, so this is again going to represent a view here of our underlying sequence from the starting at the beginning and ending at a given bound here. So we're just going to take like the first 5 things. Okay, let's see an example here. Iota, that's a view that we haven't looked at, but if I just do take and I look at the n number of things here, which I don't know if this is a super great example, but you know, take 1 will give us just 1. Take 2 will give us 1 and 2. Take 3 will give us everything there. So let's just try this out here. Okay, so I ran this. I got a bunch of combinations of things here. And what I want to do now is say, okay, I do want to sort of collect my range here. Let's do standard view. Okay, let me make sure I get this right here. Views. Okay, and I'm gonna just type these out here. Standard views. Take. How many things do I want? That's the only other argument here, as demonstrated there. So let's go ahead and just say take 5 here. Okay, and again, then I'll pipe this over here. Okay, let's save this. Let's run this and see what happens. Okay, so it does give me 5 things that I want here, but you know, they're all Mike here, which probably isn't very interesting as far as our units go here. So what can I do here? Well, let's go ahead and randomize this a little bit. Okay, and what's something that we can do to randomize? Well, let's look at our algorithm library here. Okay, let's see if we have some handy things here, and I can tell you we do have some handy things here. So let me look at our algorithms. And in fact, if you've been watching all the videos here, we should have standard ranges. Actually, let's see, maybe this is in views here. Let's go back here for the one that I'm looking for. Where is shuffle here? That's actually what I'm looking for. So sorry to give you the spoiler alert here. Shuffle. Okay, there it is. Oh yeah, sorry, it's just ranges shuffle here. So we can randomly rearrange elements in a range. Okay, so let's go ahead and take a look at this because in practice, I just want the random number generator here. So let's go ahead and include algorithm. All right, and then here, let's go ahead and call our shuffle here. Now to do the random thing here, standard ranges, and I need to pass in the random generator here. I'm just going to use this one here. It's using the Mershon Twister random number generator here. I just want to generate something here. I only need to do this once here. So these are the types of things that we usually just need, like a random seed somewhere here. And yeah, let's put it in here. Now again, ordering is always important when we're composing these views here. So let's figure out what I'm doing here. So I've got the view here. I want to do the shuffle, but I only want 5 of these things here. Okay, so I mean, if I put this in here, if I say, hey, let's actually take my range here. Okay, so that's going to be a little bit of a problem with our ordering here. Okay, so I got to think about this just a little bit here, right? Because there's a difference between views, which are the things that give us a lazy view and something, and then ranges is like, yeah, we're actually doing something with the mutatable state here. So what can I do here? So let's not necessarily eagerly just take this here. I could compose here in my pipeline, or I could make this, again, a separate step here, right? So I could have like all possible random units. Let's just call this all possible random units. Or many combinations of random units, right, that we will create. Okay, and we're not going to do the take 5 here. Let's go ahead and set that up here. Let's rename this here, all possible random units. And then let's go ahead and just say all possible random, let's call this a better thing, all possible units, all possible random units equals standard ranges, shuffle, and then I'm just going to pass in all possible units here. Okay, and then here I'll just do the views, and let's go ahead and just do take 5 here. Okay, and then let's talk about this piece of code here a little bit. If I get it completely right here, let's see what I messed up here. Let's see, shuffle, ranges, stood, ranges, shuffle. I need to pass in the random number generator here. And let's see here, random device, that probably means I need to add in, what is the header file for this? How would we figure it out? Well, let's just click on that here, random. Okay, simple as that here. Include random. All right, let's see, getting closer. Let's see, what did I mess up here? Actually, willing to bet it's this line here with a shuffle, but let's see here. Because I could just, let's see here. Yeah, I want to store this result here. I could just mutate all of our possible units here. Let's go ahead and do that. So again, this is why this is kind of an interesting piece of code here. Let's just do it on all possible units, and this is going to be something like that here. Let's see if this gives us our desired result. It simplified our code a little bit here. But this looks reasonable. I mean, this achieved our task. Right now I've got some of Arthur with some different combinations, Merlin. Let's see, let's run this a few times. Let's see if we get some Arthur, Merlin, and Mike's to show up here. I mean, you get the idea here that I'm able to take 5 here. And again, I could take this step here and move it outside of the loop. So again, just to be explicit about what I mean by this, I could take something like this. I could yank it out here and do something like this here. Auto capture 5 units, something like that here, and then I could do the standard ranges 2 thing here, and create the vector if that was important, right? And this might be important, right? In a game, you might want to have like this repeatable step here. This is example of capturing and storing those 5 random units. Okay. So again, I could do that, and then we would just put capture 5 units and replace this bit of code here. Okay. So I don't know, what do folks think about this? I mean, this is kind of interesting. I mean, from a performance standpoint, you know, if the problem is stated as give me all possible, you know, or give me many possible combinations of things, so the Cartesian product, right, where I can have Mike with all the different health and magic combinations here, this seems reasonable. I might want to store those, and then I can shuffle them around. I might want to make a copy of this original thing here. So again, if you're doing this task many, many times, and then you're like shuffling to create many different you know, versions of this sort of thing here. I mean, it might not matter if it is just random, right? I could just literally keep reshuffling this every time if I wanted to make things like more random for whatever reason, but usually one shuffle would be enough, right? And then I could make things testable by making sure my random number generator has the same seed, like all these certain things that you might want to do here for this task. But so that's something that we could do. I mean, I'm fairly happy with this code. And then the take 5, and again, if it's really important that you capture that set of 5 because maybe you want to like do this 3 different times where you generate 3 sets of these combinations of things and like store them somewhere, or you know, create some event where these 5 things are created, that could be reasonable. So anyways, few decisions here, but the whole point, I suppose, of this video is we got to learn about Cartesian product and take here, and also got to review shuffle, which we've studied in algorithm. And again, we're able to find most of those algorithm in ranges again, and solve kind of an interesting problem here. So these are the types of things that you can play around with, you know, if you're playing a game or something, and think about, hey, how would I solve that problem? Or if I had the AI opponent, the computer that you're playing, and you wanted to add some randomization and say what kind of units are they generating and these types of things. I don't know. This could be some sort of way to think about things. So anyways, curious your thoughts here. If you have better ideas of how you would approach this problem, please feel free to let me know. As always, check out course.mshut.io, drop a line in the community there if you'd like to, if you're already part of it. And otherwise, keep track of your progress on the C++ series there. And yeah, let me know if you're creating RTS games and doing cool things, because I don't know, those are fun games to play, and I think they would benefit from you know, using, well, I suppose I shouldn't say what they would benefit from the you know, standard algorithms themselves or ranges, but I think this is the type of maybe algorithmic building blocks you'd want to solve some of these problems. So anyways, if you know better, feel free to let me know, and I'll look forward to reading your comments there. So anyways, thanks for your time and attention on this video. I hope you had fun. I had fun just kind of thinking about this as we went along, and I'll look forward otherwise to seeing you in the next episode.